We're going to talk about the search optimization service. And in our test, we received 25x improvement, 100 seconds without it, and 4 seconds. So it's a significant improvement in the query speeds. This could vary a little. We've seen anywhere from 10 to 25x often. And at one company, across 16 million jobs, it has reduced file scan by 99%. And one way to think of it, it's analogous to online availability, online rebuild to non-clustered index in a traditional relational database management system. The pains of traditional non-clustered indexes, you have to often have a offline rebuild, so that when that's rebuilding, you might need to have an impact on your current query performance. But with Snowflake, it's automatically rebuild for you, and there's no noticeable degradation in your query performance. So this is in public preview right now, search optimization service. As you can see, if we go to that documentation, it's a preview feature and it's an enterprise edition feature in case you wanted to learn more about it. So our hypothesis is that search optimization service cuts compute costs by optimizing performance at a fraction of the current developer time. And the challenges with the current state is the point queries like select, update, delete, and merge queries are slow. Queries not searching on a clustering key are slow, and analytics could be delayed. Customers would use less efficient approaches to speed up these queries, i.e. they would use larger warehouses, materialized views, or clustering. The customers would buy and maintain a separate system, let's say it's an OLTP or NoSQL or possibly Elasticsearch outside of Snowflake, but that introduces data silos and additional systems to maintain and licensing costs, so on and so forth. So in our future state is a demonstrated 25 times improvement on query duration with the use of search optimization. The 4 DML operations that you see here sped up: select, delete, update, and merge. Users and applications get the data and answers they need in seconds, no user frustration from slow queries, and reduce costs by being able to use smaller virtual warehouses for these queries. And finally, fewer data silos and complexity by running these queries and workloads in Snowflake and not somewhere else. So sum it up, the 3 business outcomes are cost optimization due to reduced compute needs, significantly faster query performance, and a better experience for your users. So how do we set up this demonstration? Created a database called FeatureDB, created a schema called search, and we're using a POC warehouse. So you see here's this FeatureDB, created a schema called search, and I created this store sales denormalized SOS transient table using this query right here. As you can see, it's from the Snowflake sample data that everybody has access to, scale factor 10. It's an inner join of these 3 tables, and it creates it in a normalized fashion. So that takes about 15 minutes to build on a 3XL. So that's about 26 billion rows and 2.8 terabytes of data. I recommend after you complete your test, you drop this table so that you don't have to pay for the storage costs. So we're to set up the same thing test, you would alter the table and add the search optimization for it. And to see what it's like, what's going on, you can run this show tables like store sales denormalized. So when you show tables on this command, you're going to see that there's 3 additional columns added. Search optimization is on, meaning that it has search optimization. Search optimization progress shows you the percentage of progress. 100% means that it is up to date. So if in the event that you're initially building it, or it takes about an hour to rebuild, or let's say the service kicks in every hour to rebuild, your rebuild times may vary, but essentially as it's building up, you're going to be able to see the optimization progress. So 100 means that everything is ready to go. And the search optimization in size in bytes. This is obviously a very large table. So the search optimization service uses, on average, we've seen about 25% of the table size to be used toward the indexing. And okay, so here we're gonna use a extra large warehouse. And we're gonna make sure we're not cheating by disabling the query cache. We're gonna suspend the warehouse. It's good that it was already suspended. And now we're gonna resume this. So that way we're ensuring that there is no caching involved either on the global cache or on the virtual warehouse cache. And so we're gonna see the query plan. Now in my initial test, this took 4 seconds. I've seen this vary a little bit. Let's see how long it goes, and we will run the numbers again if we don't see 25x improvement. Okay, so in this time it took 8 seconds, so twice the amount of time, but that's still very fast. So let's go to the query plan. When we look at the query plan, we're going to see right here, this is what we want to see. It's accessing the search optimization service. And as you can see, it's just a regular select query against a table. We didn't have to specify use the search optimization. It was smart enough to know, okay, I have a search optimization service here. And as you can see, this is what we love seeing. The fraction is a significantly smaller fraction of partition scan versus the available partitions. And as a result, the byte sent over to the network and the byte scan is significantly smaller. So as you can see, the total execution time was 8 seconds. Now, if we compare this with the base table, so we're going to change our schema to use this sample data here, and we're going to run this on the same extra large server, and it's going to take about 1 minute and 40 seconds. So let's fast forward this a little bit. All right, our query has completed. It took about 1 minute and 44 seconds. Let's go to our query execution plan. And as you can see, the time is spent on the table scan, and it had to have a lot more partition scan because it wasn't able to use the servers, the search optimization servers, and the byte scan is significantly more. So let's come back here. Let's look at the math for that. So in my original test before, it was 100 seconds divided by 4 seconds improvement. So that's a 25x improvement. But let's see this one. This one took 1 minute 44. So 60 plus 44 is 104 seconds divided by the 8 seconds in our first test. So we still get a very respectable 13, as you can see, 13 times improvement right here because of the results of the search optimization service. So as you can see, to sum up our business outcomes, cost optimization due to reduced compute needs, significantly faster query performance, and a better experience for your users. Thank you very much.